You're going to take a quiz, not a test. Yes. Okay. So L'Hopital's rule. No, I'm good. I will abbreviate it as LR because I get tired of writing L'Hopital all the time. So this says to suppose that we have two functions that are both equal to 0 with a plugged into them, and that the functions are differentiable. I really wrote all those words there. I was just listening. I mean, doing the same thing.
Is this supposed to be interval 1? In interval 1,
Interval I.
Oh, okay.
Are we having a final?
Say that again.
We're having a practice, right?
You're having the presentation as your final. Yeah.
Are you gonna grade them like super harshly?
I will grade them like I grade tests and quizzes. But your peers are also going to grade you. So I should average out. Yes, you have to dress professionally.
Oh,
So like the way the presentation looks, how fluid you were in the presentation, if you answered all the questions, all of that will go into your points.
Isn't there room?
Yes, I will give it to you, just not yet. So pretty much what L'Hopital's rule says is if I take the limit of a function as x goes to a, and my function is f over g, so it's a division of two functions. If I get an indeterminate form 0 over 0, then this is equal to the limit as x goes to a of the derivative of my top over the derivative of my bottom with a plugged into it. I know it sounds really confusing, but we will do a couple, actually several examples, and it will make more sense. So when we're using L'Hopital's rule, we only have to use it if the resulting limit is an indeterminate form. So the indeterminate forms that we are going to use will be listed here. So the indeterminate forms where we can use L'Hopital's rule are 0 over 0 or any of the infinities over an infinity. So it can be negative infinity over positive infinity or positive over positive or negative over negative or a mix. The example that we are going to start with is to evaluate the following. We have lots of examples, but we're not going to do all of them because I think you'll pick up on it pretty quickly. So example A is to take the limit as x goes to 1 of x cubed minus 1 over 1 minus 1. Not 1 minus 1, x minus 1.
Every time it's
Whenever we are presented with a limit problem like this, our first step should always be to plug in whatever this number is to the function to see if I get an answer. So that's what we're going to do first. I'm going to do 1 cubed minus 1 over 1 minus 1. And what am I going to get then?
0.
0 over 0, because 1 cubed is 1 minus 1 is 0, and then 1 minus 1 is 0. So if that didn't come out to be 0 over 0, if it came out to be a whole number or a fraction, then that would be our resulting limit. But because it came out to 0 over 0, that's an indeterminate form, and I can now use L'Hopital's rule to find the limit. So L'Hopital's rule says that I'm now going to take the limit as x goes to 1 of the derivative of my numerator over the derivative of my denominator. So what is the derivative of x cubed minus 1? 3x squared. So that's my new numerator. And then what's the derivative of my denominator x minus 1? 1. Because the derivative of 1 is 0 and the derivative of x is 1. Once I've taken the derivative of my top and my bottom, I now plug this limit value in to see if I get an answer. Sometimes we have to use L'Hopital's rule more than one time. Sometimes we don't have to use it at all. Sometimes we only have to use it once. So now what I'm going to do is I'm going to go ahead and plug 1 in for all of my variables and see if I get an actual answer. And do I?
Yes.
Yes, I just get 3. So the limit as x goes to 1 of this equals 3.
That's it.
That's it. That is L'Hopital's rule.
Okay.
It is an alternative to graphing said functions to find the limit or making limit tables from the left and the right. So this is just an alternative way of solving for the limit of an indeterminate form function.
Okay, so if it was limit goes to 2, you plug 2
Yes.
x to get it to 0.
Yes. Yep. And not all the ones on your homework are going to be L'Hopital rule functions that we can use. So if it doesn't come out to an indeterminate form, we need to find another way to solve that limit. Okay? So we're going to do another example. Yes, Devin.
Recording.
I am.
So do we just, whenever can take the limit?
Yep. You stop whenever the limit works.
Well, because if we were to go one more, it would change the limit.
Yes, that's why we stop right where it works. Yeah.
Is it possible not to?
And actually, no, we couldn't do it again because I get a 0 in my denominator and that doesn't work. Do that again, honey.
Okay, never mind.
Yeah. It works that where you stop is the exact answer and you really can't go that much farther. Example B is the limit as x goes to pi over 2
This is where I lose my brain.
of cosine squared x over sine x minus 1. The first thing I go ahead and do is I rewrite cosine squared x as cosine of x squared over sine of x minus 1. That usually makes it a little bit easier for me to plug it in. Also, we should be in radian mode for these problems. So what's my first step when I'm faced with a limit problem like this?
Again.
Plug in that limit value it's asking me to evaluate at. So I plug in pi over 2 for x. And when I do, I get what?
I got a math error.
Okay, so you should not plug it in all as one fraction because if it comes out to be a 0 on the bottom, your calculator is not going to let you do it. So you should just plug in the numerator, get an answer, and plug in the denominator and get an answer. 0 over 0 is what it should be, which is why your calculator wouldn't let you calculate it. Does that make sense? So we do the top individually, get an answer, and then we do the bottom individually, get an answer, because if we divide by 0 in a calculator, it goes syntax error or undefined, or it doesn't let you do it. Which means, since it came out to an indeterminate form 0 over 0, what can I use? L'Hopital's rule, which says I'm still taking the limit as x goes to pi over 2, but this time I'm going to be taking the limit of the derivative of the numerator over the derivative of the denominator. It might not be a bad idea to do your derivative work off to the side. So that's what I'm going to do over here. So what is the derivative of cosine of x all squared? So this right here.
Negative 2 sine. -2.
No, cosine.
It's chain rule. So that's going to become 2 times cosine of x times the derivative of cosine of x, which is negative sine of x. So that derivative is actually -2 cosine of x sine of x. All of your derivative rules still apply. So that is my new numerator.
This is new.
Well, you have a calculator, so it's really not that bad.
Ow.
And then I go ahead and take the derivative of my denominator, which is sine of x minus 1. The minus 1 goes to 0, so I don't have to worry about it. What's the derivative of sine? Cosine. So my denominator just becomes cosine of x.
Okay.
Before I plug in pi over 2, I can look to see if it simplifies first. Does this simplify at all?
Cosine.
Yeah, the cosines cancel because I have one on the top and one on the bottom. So the function I'm actually plugging into is -2 sine of x.
That's it.
And then I just plug it in and see what answer I get.
So will this work with like everything that you can't just direct evaluate?
Everything that would give you an indeterminate form if we were to direct evaluate.
Is it -2?
It is -2. Because sine of pi over 2 is 1. 1 times -2 is -2.
Seems like the right way to do it.
How do we feel so far?
Good.
Worst thing ever, not worst thing ever, not
I can
terrible.
remember my derivatives.
Because
Yeah.
it gives you an exact answer for a limit.
Excellent.
I'm just gonna start
Oh,
calling
boy.
it.
We're not doing that one yet.
Oh.
Well, that comes out to 0.
That comes out to what, Erin?
0.
0 over 0 when I plug it in, correct? Which means I can use L'Hopital's rule,
This is probably going to
which means I'm taking the limit as x goes to 0 of rotary. What's the derivative of sine of x? Cosine. And then what is the derivative of x, rotary? It's a general rule. 1. My new function that I'm plugging 0 into is cosine of x over 1 or just cosine of x. So what happens when I plug 0 into that? We get 1 over 1, which is just 1. Cosine of 0 is 1.
Wow, I like this. And then it's going to get harder. You're going to be like, whoa.
The only thing that's to get hard is differentiation.
Questions, concerns, or issues so far? No? We're all okay?
Hours.
So let's say that I have something along the same lines as that problem. Still taking the limit as x goes to 0, but this time the sine of x over x squared. It is not the same. The previous one was sine of x over x.
Yeah, but you're square.
Right, so when we plug 0 in to start with, I'm still getting 0 over 0, right, Deanna? Which means now I can apply L'Hopital's rule. And then when I apply L'Hopital's rule, I get the new function to be what over what?
Cosine.
Cosine of x over 2x. So what would I do here? I get 1 over 0, because cosine of 0 is 1, but 2 times 0 is 0. This is not an indeterminate form, so I can't use L'Hopital's rule again. So I need to find a different way of evaluating that function at 0. So this is where our other limit rules and properties come into play. One thing we could do is we could graph it and see what's happening at x equals 0. Or we can do a left and a right limit. And that's the way that we're going to practice now because it's been a while since we've done limits.
Left and right.
So we're gonna do the limit as x goes to 0 from the left, which is 0 with a little negative, of cosine of x over 2x. And we're gonna do the limit as x goes to 0 from the right, of cosine of x over 2x. And we can plug it straight into our calculator, which makes it really, really easy.
We're gonna do this.
Yes.
Why wouldn't we just do the original?
You could have, but we didn't necessarily know it wasn't gonna work out. So there are, as I said before, L'Hopital's is just one way or one alternate way of solving a limits problem. You could have done this from the start on all of them and it still would have worked out fine. Okay, so we need to pick a number immediately to the left of 0. What's a number that's immediately to the left of 0? Negative 0.00001. That's a really good to plug in. So we're going to plug in cosine of negative point, and we're going to do 3 zeros and a 1 over 2 times, same number, and we're going to see what it comes out to be.
Okay, so that's for the negative.
Yes.
If we were to do L'Hopital's rule again, would it just give us a wrong answer?
Yes. In theory, because that's not an indeterminate form. What are we getting when we plug in that negative 0.0001?
-4, 9.
So a negative big number, right? Which we can generalize as negative infinity. Everybody getting a negative big number? Yeah, so that's how we generalize. So we would say that as we go or approach 0 from the left, it's going down to negative infinity, which a graph would support. Now we do the same thing, except this time we're coming from the right. So what's a number really, really close to 0, but from the right? So positive. 0.0001. Same concept, just this time we're plugging in a positive number that's really close. Yes, Erin. What do you mean you don't know what's happening?
Like, do I put that all together?
In your calculator? Yeah. This divided by that would have been a way to do it. Are you not getting that?
No, but hang on.
Okay. Okay, so what do we get on this one? A positive infinity. So this is where that limit property comes into play. If my left limit does not match my right limit, what is my overall limit? Does not exist. What if they did match?
Then
Then the limit would be whatever number they came to on both sides. So you guys do remember some limit stuff. So that means that my overall limit up here does not exist, as proven by our two one-sided limits. How are we doing so far? Good, not good, terrible, fine. Okay, so we're just gonna do one more, so I think you kind of get the hang of it. The hardest part is just remembering what all of your derivatives are. Okay, so that might be the part that trips most of you up. So we're gonna jump right to the last example, or not the last one, but pretty close, and go with it. So this one is going to be 50.
Yeah.
Okay, this will be E. And this is the limit as x goes to infinity of x squared over e to the x.
Just gonna be 0.
It's gonna be what?
0.
Over what?
Well, it would be some number over the number that we gave.
Is it
Give me an overflow.
Gave you an
I got
overflow.
0.
I'm hearing like indecisive answers. Did you, you might have put too many numbers in. Yeah, so you might just have to put less 9s in. So let's treat them independently because maybe sometimes putting them together gives us an issue. What's infinity squared? Infinity. What is e to say like 999? It's a very big number.
But it's bigger than the one on top.
We don't necessarily know that for sure. So what I have now is I have an indeterminate form, infinity over infinity, which means that I can use what? So let's use L'Hopital's rule. Which gives me the limit as x goes to infinity of, what's the derivative of x squared? What's the derivative of e to the x? So then I plug it in again. What can I already guess this is going to give me? Infinity over infinity, because 2 times infinity is still infinity, and e to the infinity is infinity, which means I got another indeterminate form. So I get to do what again? L'Hopital's rule again.
So you take the.
Yep, so now I'm going to have the limit as x goes to infinity of what's the derivative of 2x?
2.
And what is the derivative of e to the x?
E to the x. 2.
And I get 2 over infinity, which equals what?
2 infinity. And beyond.
Little over big equals little. Big over little equals big. It's the best way to remember that.
So what? So,
Little over big equals little. So little number over really big number equals 0. And then big over little equals big.
But isn't that big over?
No, this is little over
so
big.
like if it was infinity
Yeah.
over 2, it'd be infinity.
Correct. Yes. So as Liam already pointed out, it was 0 because the bottom was growing much faster than the top. But this is a really good way of proving that without having to do some magnitude stuff. Questions, concerns, or issues so far?
Oh, really?
No, we're okay?
Yeah.
Okay, your homework is on Canvas. Feel free to start working on it. It is 10 questions. The instructions are very clear. You have to first determine if you can use L'Hopital's rule. If you can't, find some other way of evaluating the limit. If you can, you are expected to until you can't anymore, and then that should give you your answer.